Hello everyone, myself Pushpender Singh. Today I am going to discuss chemical kinetics chapter. This is a very important chapter if I talk about JEE and NEET point of view. So what will we discuss in this chapter? First of all, chemical kinetics. So to study any chemical reaction, there are three factors that are very important. First of one is feasibility of reaction. Feasibility of reaction. Whether the reaction is feasible or not, or it is discussed in thermodynamics. As we know, if the Gibbs free energy change delta G is less than 0, then reaction is feasible. And if delta G is greater than 0, then reaction is not feasible. The second factor that we should know, that is extent of reaction. At what extent reaction is occurring, and it is discussed in chemical equilibrium. We discuss law of mass action. And the third and most important thing that we discuss in this chapter, that is called rate of reaction. At what rate reaction is occurring. So basically, chemical kinetics is a branch of chemistry that involves study of rate of reaction, factors affecting rate of reaction, and the mechanism involved in the rate of reaction. So we will understand the type of reactions on the basis of rate. There are three types of reaction on the basis of rate. First one is very fast reaction. Ionic reactions are the examples of very fast reactions that occurs in the microsecond. Example, precipitation of AgCl. When AgNO3 react with NaCl, it forms AgCl, precipitate, and NaNO3. It is an example of very fast reaction. Second one is very slow reaction. Example of this reaction is rusting of iron. The rusting of iron process takes years of time, so it is example of very slow reaction. And third one is moderate reaction. We can't study the rate of very fast reaction as well as very slow reaction. In this chapter, we will discuss the rate and mechanism of moderate reaction only. So we will understand what is the rate of reaction. So rate of reaction. So let us suppose n reactant R that is converted into product P. So the rate of reaction can be expressed as the change in concentration of reactant or product in unit time. The concentration of reactant will decrease with time and the concentration of product will increase with time. Let us suppose at time t equals to 0, concentration of reactant is R1 and concentration of product is 0. At time it is considered as R. Time t1 it is R1 and it is P1. At time t2 concentration of reactant is R2 and concentration of product is P2. So as we know that concentration of reactant will decrease with time, so R2 is lesser than R1 and concentration of product will increase with time, that's why P2 is greater than P1. So if I talk about what is the rate of disappearance of reactant, what rate of disappearance of reactant. So initial concentration of reactant is R1, final concentration is R2, it is at time T1, it is at time T2. So rate of disappearance of reactant will be R2 minus R1 upon T2 minus T1. And as we know, R2 is lesser than R1, so this will be a negative quantity and rate cannot be negative. That's why we use negative sign here. This negative sign indicates that the concentration of reactant is decreasing with time. Now I will talk about rate of appearance of product. And this can be also written as minus delta R by delta T. Rate of appearance of product, it will be P2 minus P1 upon T2 minus T1. Since P2 is greater than P1, that's why we use positive sign here, that is already positive, and it can be written as delta P by delta T. So this is all about the rate of disappearance of reactant and rate of appearance of product. Now I will discuss about rate of reaction in term of stoichiometry. So rate of reaction in term of stoichiometry. Let us consider a chemical reaction in which A mole of reactant A react with B mole of reactant B to produce C mole of product C and D mole of product D. And if it is given to us that write the rate of reaction for this reaction. So what is the rate of reaction? So rate of reaction is basically rate of disappearance of reactant oblique rate of appearance of product upon that stoichiometric coefficient. For this reaction, if I would like to write rate of reaction, so rate of reaction will be minus 1 upon A delta A by delta T equals to minus 1 upon B delta B by delta T is equal to plus 1 by C delta C by delta T is equal to plus 1 by D delta D by delta T. Since the concentration of reactant is decreasing, that's why we are using negative sign here, and in product we are using positive sign. So in short, rate of reaction can be written as plus minus del C by del T. Plus can be used for product and minus can be used for reactant. Second thing, we will understand why we are dividing it with their stoichiometry, because A mole of reactant A is producing C mole of product C as well as D mole of product D. That means the moles of reactant and product are not same. That's why we are dividing it with their stoichiometry, basically with their number of moles. Now I will discuss about average rate and instantaneous rate. So average rate is the change in concentration of reactant or product in a given interval of time. So it is change in concentration of reactant or product in a given interval of time. If I talk about reactant versus time graph, since the concentration of reactant decreases with time, so it will be like this. Let us suppose at time t1 concentration is R1 and at time t2 it is R2. So what is the average rate? Average rate will be R2 minus R1 upon T2 minus T1. And since R2 is lesser than R1, that's why we use negative sign here. And it can be also written as minus delta R by delta T. If I talk about product, so product concentration is increases with time. Product concentration upon time. Let us suppose at time P1 product concentration is P1 and at time T2 product concentration is P2. Basically this is in square bracket here also, because in kinetics we write concentration in square bracket. So average rate will be P2 minus P1 upon T2 minus T1, and this is delta P by delta T. And if this time interval tends to 0, then it will called as instantaneous rate. So instantaneous rate is basically, it is average rate at delta T tends to 0. So R instantaneous will be limit delta T tends to 0 delta C by delta T plus minus delta C by delta T. Plus minus here we are using, plus is for product and minus is for reactant, and this can also be written as plus minus dC by dt. And as we know in physics, we study that dC by dt is basically slope of your graph. So if I plot the concentration versus time graph for reactant, and if I ask to measure its rate at a particular point, let us suppose this point, then how will I measure instantaneous rate? So the instantaneous rate will be the slope of the tangent drawn at this point. So this is the tangent and this is the angle theta, and tan theta barabar dr by dt. Here theta is a obtuse angle, that's why tan theta is negative and this quantity will be negative. For reactant, the instantaneous rate is negative. If I talk about product, if I have to measure instantaneous rate at this point, so I have to draw a tangent at this point. This is the tangent. It cuts x-axis here and this angle theta. Basically this is a acute angle, so here tan theta is positive, that's why dp by dt will be positive. So R instantaneous will be plus का dp by dt. So this is all about average rate and instantaneous rate. Thank you very much.